Today we continue to work on our snake game clone, and this episode's main topic is player snake and handling its movement. So last time we managed to draw our grid. We have different states for each tile. The empty tiles are smaller in size and they are also animated, while we have this visited tile which is static but more pronounced. There will be different tile states as we go along. For now, I would like to first do a couple of changes which should have been done in the first episode. So first of all, like the window title is our game name, and secondly, I did change the empty tile color a bit so that it's more visible to you. But now that the grid is already rendered, we can see that this more faded out darker green looks much better, in a sense that it provides visual feedback that these tiles are not visited, they are pretty much empty. One last thing is that we probably want to clear this thing up. We no longer need to have this section of visited tiles. So we have our grid initialized as empty. So let's introduce a snake into our game. Snake will be used both by player and our enemy clones. So we need to define the properties that will be shared between them, and in case something is needed for player that is not needed for clone, we can define it outside in a different structure. So snake will have some tiles that it consists of. So snake has length. It consists of like parts which are represented by some position on the grid. So they're represented as position on our grid as being tiles. I named them tiles, but they're really like position of snake parts. So let's define them like a position tiles. This is an array of squares that this snake is currently occupying on our grid. The position struct is as easy as row and column. Next, each snake, whether it's player snake or enemy clone snake, will have a value property that applies this tile state onto the grid, so that we can render the grid using tile states, and each tile state is rendered differently. Now, final thing that we probably need right now is the direction of the snake. So usually the snake is moving into some direction. So let's define that as dir, and we need to define what direction is. It is an enum, which can be like up direction, down direction, left, and right. Now our game has snake player, right? So this is our global state. When we initialize the game, we should probably initialize our snake as well. So we can say that, hey, init some snake. As I said, our snake structure is used both by player and the enemy clones. So it's worth writing a generic init snake that works with any snake. In this case, we give it our player reference to player snake. But once we reach the section where we work with enemy clones, we will simply pass the clone here. So let's see what does like init snake does. What we need to do. First of all, let's see, we have like these three things. Right, so tiles. Snake tiles initially is null. It will be an array, dynamic array. As in our previous C-based projects, we use STB, header only library for dynamic arrays. We will introduce it here as well. Our tile state will be actually something that we pass through here. So this will be tile state value. And considering that we're working with player, we need to introduce new tile state saying that, hey, this is like a player tile. So I occupy this grid. So when we init our snake, we need to say, hey, this is a player tile. Next direction. Let's start with the right direction for all snakes. But if you remember, our clone snakes will actually be following the player's path or replaying it. Therefore, this direction won't be really necessary for them. So it's okay to set just a general direction as right for everyone and not take it as a parameter here. We should also probably say where the snake should be spawned, right? Because right now the snake pretty much says, hey, I'm a snake. I have some tiles, although like it's currently empty. So I have a length of 0. I do not occupy any tiles on the grid. So first of all, we want to say that, hey, let's spawn this snake onto grid in some row and column. And this is really not enough. We're saying that where we want to spawn, but still we're saying that, hey, this snake is of size 0, so we also need to provide some length param. Now we can actually say that for I from 0 to length, we can actually push the snake tiles start position. What is a start position? It is as easy as saying that the row and column that was passed into this function. So what we do here is we're saying for this row and column, spawn this amount of positions or tiles or whatever into the like single position. So if we pass, let's do it this way, that we're saying that let's spawn into some I mean something like this, not entirely in the middle, but really close. And let's say our initial snake is of length 3. It means we're gonna push 3 start positions. So our snake, its length of 3, its 3 parts are all gonna be spawned into a single grid tile on the start position. And once we start moving the snake, we will move it tile by tile, and you will see like how it applies. Now this array push is missing right now, so as usual we need header only. This is something that we already did. This is the file that we need. Raw, let's copy it. Let's edit the stb.ds.h, paste it here. Then as usual we need to create a C file. As I explained before in previous episodes, this is needed so that LSP doesn't go crazy. And now we can actually include this file here, stb, and our array push works. All right, there is still an error here somewhere. GetTileColor. We introduced a new tile, which is player tile. And for that, our player is going to be simply white, right? So RGB whole 255. If we run it, like everything compiles, the same grid is displayed, but there is no snake yet. This is because we're actually not displaying our snake. And to do that, we need to introduce something like snake mark tiles given some player snake. So again, this will be used both by player snake and our enemy clone snake, so they can each mark their positions on the grid using that value that we introduced as tile state. So let's see how this function should behave. Again, working with some snake. We can say that, all right, so how many tiles do we have? What is the length of our snake? We can simply ask our tiles array for the length, and then we iterate through that. So each tile is a position, right? Position P is snake tile set I, and then we need to do what? We need to say that, hey, there is a tile somewhere on the grid, tile grid. There is a position row and position column. We need to reference that and say that tile state is actually our snake value. Right, so each snake, whether it's a player snake or whether it's an enemy clone snake, will simply update our grid's tile value so that we know how to render it. We render it with different color. So right now we can see our player snake simply staying in the middle. There is no movement yet. We do have a direction, so we need to somehow animate it. Let's think how we can do that. Let's do a function, something like doStep. Again, we'll continue to use the same approach where we simply take snake as parameter, snake doStep, and our snake. So our snake has direction. We need to figure out where to move. Let's do that. First of all, we need to calculate the direction change based on snake's direction. So if snake direction is up, then dy is -1. If snake direction is down, then dy is 1. If it's left, then it's x -1. If it's right, then dx is simply 1. So we now know kind of like into which direction to move. Now we need to apply that move, and we are applying this direction change to our head tile, snake's head tile. Right? So if you think how the snake moves, it's usually its head moves, changes the position, its tail disappears, but the rest of the body remains the same, so to speak, like if you look at it visually. So we need to actually apply this direction change to the head of our snake. And that is as easy as position head, I think, is snake tiles 0. Right, so we know the head. We need to now construct new head, which is a position where row is our head row plus dy, and our column is head column plus dx. Now, because this is head, it is the beginning of snake tiles array. We need to put this new head into the beginning of the array. Then we need to push or like shift the remaining tiles to the right, and the length of the snake remains the same. How can we do that? We can do it this way, that first we shift the existing tiles. So we say that I is actually length -1, I is greater than 0. What is length? It is, as usual, size t of our tiles array. So we're starting from the last tile of the snake, move one by one to the beginning of the array, but we do not take the head, so we do not apply changes to the head, and we're simply saying that, hey, snake tiles I is snake tiles I -1. So pretty much we're overriding the last tile with its left neighbor. So the current head ends up at tiles 1, right? Position 1, because we're looping up until I equals 1. And then finally we can say that, hey, tiles 0 is new head. Let's see what it does. And we can see some interesting weird behavior. First of all, we're not moving on the same row, then we are displaying a lot of different things. So there are some things that we need to fix. All right, let's try to think. Like, what we need is probably we first need to think about this wrapping. So if I reach the border of our grid, I would like to wrap and start displaying snake on the other side. So we need to check this new head that we just calculated and ask it if new head row is less than 0, so we're outside of our grid, right? Then we need to say that new head row is rows -1. New head row is actually reach the limit on the right side, then we wrap it and it becomes 0. Same should be done for our columns. Now I'm using else if, but yeah, as we are not able to use diagonal movement, it's fine to use it with else if. But if we had diagonal movement, we should have handled column differently with its own if. So if less than 0, new head column is columns -1. And if new head column is bigger than that, then column. So this is wrapping. Nice. So the snake is now running on the same row, and hopefully when it goes up or down, it will run on the same column. The problem is that our snake is supposed to be of length 3, but right now it simply is like enormous, so infinite length or something. The problem here is that we do not reset the grid state on each frame. So last frame state is transferred to the new frame and we draw on it, so all previous drawings are still like applied to the grid, all previous changes. So what we need to do first is we need to like clear grid. Right, so void clear grid, and we can say that, hey, size, it's like for loops, again row less than rows for each column. We can say that, hey, tile is GameTileGrid, oops, TileGrid, row and column. We can say that tile state is empty tile. And now we have our snake running. We can probably say that it is of length 3, although it's a bit hard to tell because it's running quite fast. It's running fast because we do not slow it down in any way. So it is related on the FPS. So how many frames per second we are drawing, and we're drawing currently 60. So for example, if I comment this out and let it run at whatever FPS it's capable of, it becomes as fast as a bullet. So we need to address how many moves the snake wants to make independent of our FPS. So we probably want to say that, hey, let's define some step interval as 0.1. So 100 milliseconds is an interval for each step. Right? So I want to move our snake or all the snakes once per 100 milliseconds. For that, I need to introduce a step timer, and it will gonna increase each delta for each frame. We're increasing this delta, and then we do this step only if step timer has reached the stepped interval, and then we reset the timer. Let's see. Now our snake is moving only once per 100 milliseconds. So the only thing that is left is to handle our input. So I would like to key press some arrows up, left, right, and down, and make the snake move accordingly to whatever the key I pressed. All right. Okay, update. All right, so there is a small refactoring we can do right away. We're calling this UpdateTileGrid and ClearGrid almost one after another, and they both iterate through the whole grid. Right, so we do update and clear. So we can probably drop this ClearGrid and apply the change right away in this UpdateTileGrid. Right, so this shouldn't change anything, but we just dropped one useless function that we don't really need. All right, so how do we handle input? First of all, we need to handle it somewhere like in the beginning of our function. Let's say snake handle input. Again, let's path our player snake and see what we can do. Snake handle input, having our snake. Now, when I press some key, right, it won't be reflected right away because we are drawing our snake only once per interval. It means we need to somehow save whatever like the key I pressed so that later on I can actually do the adjustments here. All right, so let's see, like for snake structure, we are not only keeping the current direction, but we would also like to keep next direction. Right, so this is the direction that I'm gonna be changing to during the next step interval. We can initialize it the same as right direction, and then in our new functions, snake handle input, we can say that, hey, if snake current direction is equal to next direction, which means that this is like our interval, 100 milliseconds, during which I can press lots of buttons, depending on how fast I smash my keyboard. This actually checks that this is the first time you are changing direction. Well, maybe not the first time, because if you're moving to the right and you press the right button, right, so the direction of the snake doesn't really change. So it's actually checking whether you're changing the direction for the first time to something different than its current direction. So let's say that if is key pressed, I think, yeah, key pressed, key left. So this is something that raylib tells us whether the key was pressed. If we have pressed the left key, we would like to change the direction to snake. Next direction is going to be left direction. But the problem here is that if I'm moving to the right, I cannot move back to the left. So we need to also check that snake current direction is not right direction. Right? So we just cannot move the other way right away. We need to move first move to up or down. And same applies to all the different variations. So if I'm pressing the right, I'm making sure that we're not moving to the left. And if it's acceptable, then we can move to the right. Then it's key up. We're checking whether we're not moving down. So it's going to be up direction. Finally, key down. We're checking that we're not moving to the up. So it's going to be down direction. All right. So if we run it, I'm pressing some buttons, but nothing really changes. The thing is, we have currently only changed the data on the snake. So it has this next direction, but it is not being taken into account anywhere. And we can take it into account into our snake 2-step, saying that, hey, our direction is actually like next here, whatever you pressed. Let's see. And our move. All right, interesting. It's actually got stuck, but if we go to the right, it wraps around. If we go to the bottom, it wraps around, but if we go to the top, it doesn't wrap around. If we go to the left, it is also not wrapping around. I believe I know where the issue is. Here, there is our wrapping logic, right? Where we check like less than 0. The thing is that our row is defined as unsigned, so it actually cannot be less than 0. Although it did make sense to have position as unsigned, it is easier for us to simply say it as int and use this logic here. Otherwise, we could still use the size t for unsigned and do some ifs when calculating the new head. But I believe this is just a bit easier and cleaner. But in the long run, maybe size t does make sense. Let's see whether that helped us. So we are wrapping to the right. We are wrapping to the left. Wrapping top, wrapping, yeah, seems to be working just fine. So one thing I believe that is not working well enough with our current implementation is that we have a window of 100 milliseconds where the new direction is applied. As I said, we can press our buttons quite a few times during that small window. And imagine that the food that we want to eat is somewhere behind you on the row below you. So you want to hit bottom left really quickly. So bottom left. It seems that if you hit the bottom first and then interval changes and then you hit left, then everything works fine, right? You saw that it went to the left side correctly. But sometimes you can hit those buttons right, like now I hit it, but it went down, but it didn't go again. It doesn't go to the left. It happens because when we're handling an input, it happens in terms or in a single interval. Our first, like I'm pressing down button, it sees that, okay, it's the first time you're changing direction. It changes my direction, next direction to being down. And when I press left, it is still handled in the same interval, and this thing is not then run at all. So my left key press is actually being ignored. So I would like to try and keep track of like a queued next step. So next there is my next direction change, but I would also like to keep track whether I can or whether I want to do yet another direction change right after next one. So what I would like to have is next direction. So if I press down left quickly and it happens in scope of single interval, I would like to remember it and then apply this thing first and then these things next as soon as possible. To achieve that, we also need to introduce a flag that says, hey, do we have this next direction change queued or not? You will see why it is needed soon. So first of all, let's define next dir, which can be right direction, but really doesn't matter. What matters is that has next is initially false. So we're saying that, hey, we do not have this next direction change queued. All right, so what we can do next is probably how do we handle input now? So this handles our first direction change. And if it detects that, hey, the first direction change has already happened, then we can actually queue our second direction change. So let's just copy everything here and say that if I'm pressing left and my next direction isn't right, so because I'm queuing next direction change, it has to be compared to my previous, which is next dir. And then this is next. We do the changes to all the keystrokes. Again, this won't be reflected if we run the game itself. Nothing will change because we're simply applying the data change on snake structure, but we haven't been handling this next here anywhere. And one more thing that we need to do is to say that, hey, I have actually queued this next direction change. Where do we handle it? And we're handling it in our snake do step. So as you can see, first thing that we do is we're actually grabbing the next direction change that has been applied. We're putting it into our dir. And what we can do here in the end, once we have done all the calculations, we can say that, hey, if snake has this next direction change queued, we can of course set it to false, but first we can put it as our next direction, right? So this is not on current direction and next direction, but this is, we're keeping track of 3 directions: current, next, and next. So in a sense, we're queuing a few moves ahead. Let's see whether it works. So left, bottom, right, top. And now the test is right. So as you can see, with the queuing, I can easily do this left, right. So this helps tremendously. All right, so this is pretty much it for the snake movement. Thank you very much. If you like this video, please do like the video itself. If you like the content, please do subscribe to the channel. It helps me greatly. And I'll see you again. Bye.